All right, everybody, we just got our okay to start our planetarium show. So for now, folks, I'm going to be changing the vibe in the room real quick. And welcome everybody to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm an actual person. I'm standing right behind you at the very top of the planetarium. Hey, good afternoon, everybody. Good to see you. Don't hurt your necks, though. Look forward into the dome before you. That's where the whole show's going to be. I just want to let you know that I'm an actual person, not AI, at least not yet. And everything that you see in purple right now, folks, is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for a projector system, it's hidden just below that purple glow. And folks, the show that we're about to watch right now is hands down my personal favorite. This one's called Tour of the Universe. And this show is completely live, which means you're going to be hearing my voice for the next 30 minutes. And what this show entails, well, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things, so just a forewarning. And before we get started, I got to go over some quick house rules, just so that we're all on the same page. First off, folks, there's no food or drinks allowed in. If you brought any snacks, make sure those are put away till the end. We want to keep this place as clean as possible. Also, if you happen to have any cell phones, smartwatches, anything that produces really bright white light, now is a good time to put that away for the next 30 minutes, as these can be very distracting and takes away from the planetarium show experience. And folks, if you need to leave early, the exits will always be at the very top of the planetarium, so always make your way up the stairs to exit. And if you have trouble climbing the steep stairs, don't worry, we understand. All you have to do is just remain seated. Once the show's over, we'll have a staff member escort you to a lower exit, so you don't have to climb those steep stairs. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you have to do is close your eyes, taking a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling all the way towards the edge of the observable universe. At least not more than the usual. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, and let's begin our tour of the universe. All right, let me just regain control of our flying software. And folks, like I said, we're starting off pretty close to the Earth, not right on the ground, but just above it, here at this really cool spacecraft called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey Christian, what is the International Space Station? I hear about it all the time in news, articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks, the International Space Station is a research facility. It's a laboratory that orbits around our planet Earth. And they conduct all different types of experiments up here that's a little bit more difficult and has less gravity. Some of the experiments they'll conduct are things like what happens when you try to grow plants in space? Do the plants grow the same? Which way do the roots grow with less gravity? Another one of my favorites is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity as well? And my personal favorite is where they had 2 identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for the year, and after the year, they compared and contrasted the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower, but not only that, you also lose a lot of muscle because you don't have gravity constantly working down your muscles as much. So if you plan to live in space for a long period of time, remember to exercise daily. And also, folks, the International Space Station looks huge here on our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, that's okay. You can also use the entire California Academy of Sciences, the museum we're sitting in. That's roughly how big it is. And also what's incredible is that this thing is going incredibly fast. The International Space Station's traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, this looks really far away from our planet Earth, but it's not too far either. The ISS is only about 225 miles above the surface of our world. 225 miles, that's not too bad. That's like going from San Francisco to Santa Barbara, a nice little road trip with the family to get away for the weekend, so not too bad. But to tell you the truth, folks, this is as far as we put humans into space nowadays, only 225 miles above the surface of the world. The reason why is because traveling into space is quite costly. You gotta build yourself a rocket ship, or buy yourself one, or pay for a ride to get all the way out here. And then once you do that, you have to account for all the rocket fuel. You're gonna need so much rocket fuel, you gotta be able to escape the Earth's gravity. And once you acquire that, you also have to account for all the food, water, all the air you're gonna be breathing while you're up here in space, so the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop in our tour of the universe. So now we're gonna see it slowly fade away down to the landscape down below. It looks like we're hovering just somewhere above Northern California and Oregon. And before we lose track of the ISS, I want to add a nice little orbital path so you can see it as it slowly disappears. All right, folks, now we've zoomed all the way out and we're now able to see our entire planet Earth. And I want to let you know that the space program that I'm using here inside the Morrison Planetarium is something that you can go home and download, and you can fly through space just like how I'm doing right now. The space program that we're using in here is called OpenSpace. And if you want to download it, go to your favorite search engine, type in OpenSpace Project, and you'll come across the link where you can download this. I also want to let you know that this program is not finished. It's in its beta phase. So we may come across a few bugs and glitches here and there. If we do, I'll point them out. Hopefully we can look past them, although they've been really good lately, so we haven't had any issues. Knock on wood. And also, folks, this program uses a whole lot of processing power and information. It pulls from almost real-time satellite data sets. So if you have an older computer, you may want to get a newer one, or if you know computer programming, then you should download this. But if you got something older, you may want to rethink that because it may overwhelm that older computer. But if you got something new, like a gaming computer, give it a try. It's a whole lot of fun. And also, if you're a person like me that doesn't want to download anything, you just want to fly through space because it's so much fun, well, we also have another great alternative called NASA's Eyes. Just like the human eyeball, type in NASA's Eyes to your favorite search engine. Don't have to download anything, and you can fly through space, and it's so much fun. But in here, we're using OpenSpace. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before, but that was a little while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars. But before we send humans deep into our solar system, we got to figure out how exactly we're going to be living out here in space. So the moon is the perfect stepping stone how we're going to be figuring out the logistics, how exactly we're going to be doing that. And what's really amazing is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there, and that's going to be very helpful because we can melt that ice, pass electricity through it, we can separate the hydrogen and the oxygen, and both that stuff's very valuable when you're really far from home. So look out for any news about Artemis in the coming years. We humans should be heading back relatively soon. And folks, when we look up at the moon here from planet Earth, sometimes it feels so close that you can reach out your arms and touch it, especially when it's close to the horizon. But the moon's really far away. It's about 240,000 miles away from our planet. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months, non-stop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. Astronomers instead use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to see the moon and the Earth in their orbits as they start to slowly fade away, just like how we saw with the International Space Station before. And just like before, I want to add some nice trails so we can keep track of everything, because again, space is so big. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, showing us the most accurate images and information available to us. And now the nearest star to us comes into view, so here comes the sun. Do-do-do-do-do. And the sun is also incredibly far away. It's about 93 million miles away from our planet Earth. 93 million miles. In terms of speed of light, that's not too far away. That's only about 8.5 minutes at the speed of light. And again, we're the third rock from the sun. We've got 1 planet, 2 planets, 3. We're on the right-hand side. And again, 93 million miles between us, 8.5 minutes at the speed of light. And this is a really cool concept to keep in mind, folks, because let's say the sun was to turn off all of a sudden, that last bit of sunlight will travel that 93 million miles, that 8.5 minutes at the speed of light, and then all of a sudden the daytime on Earth would become nighttime. And again, this is such a cool concept to keep in mind because let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when you look at really far away objects in space, it's like looking back in time in a sense, which is pretty cool. But now that we got a nice bird's eye view of our solar system, let's do a quick refresher. Right in the middle of our solar system, we have our star, the sun, the biggest thing. Closest planet to the sun, we have Mercury. Then we have Venus, Earth, that's us, and then Mars. These are all the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have the main asteroid belt. And this is what it would look like if we were to highlight all those asteroids. There's roughly about 1 million asteroids in the asteroid belt, so lots of space rocks. Want to look out for those. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all. Saturn, famous for its rings. Then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And we can always add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen, just at the very top of our solar system. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. The Kuiper Belt is essentially a second asteroid belt past the orbit of Neptune. And what you're mostly going to find are icy asteroids and short-period comets. Comets don't stray too far away from the sun. And what's really interesting is that in 2006, our telescopes, our technology greatly improved, so we're able to find much more objects much further away from the sun. And And we found more than 400 objects out here, and some of this stuff was bigger than Pluto, so we couldn't call all these things planets. There was just way too many of them. So all the astronomers on planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And folks, they came up with 3 different criterias, and that was the day in 2006 that Pluto went from being a planet to a dwarf planet. And I know a lot of people have hard feelings about that. Trust me, I still do a little bit. But there's a good reason, because as our technology gets better, we're able to observe much more objects, and we can reclassify things as they fit better into our models. So that's a really cool thing about science, because as it's constantly updating and changing. But I want to put away the Kuiper Belt because that's just a whole lot to look at. I want to put up all these different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. All of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even in the most distant of these robot adventures, Voyager 1 has not traveled as far as light travels in a single day. In order for sunlight to go all the way out to the orbit of Pluto, takes sunlight about 5 hours at the speed of light. 5 hours, not too bad. But now it's time for us to leave our planetary scale behind and head out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. Oh, look at that. Alpha Centauri is just on the right-hand side of our screen. So again, we're right in the middle, our solar system. Right-hand side, this star that's moving a lot, that's Alpha Centauri. And again, 4 years at the speed of light just to reach the next star system to us. But folks, that doesn't really put into perspective of how long it would take us to travel there. If you were to get in a rocket ship of today's capabilities, made your way over to Alpha Centauri, the closest star system to us, it's going to take you about 8,500 years to make that journey. Whew! And that's just a one-way trip. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now, folks, we're going to be stepping inside something called the radiosphere. And again, folks, we're now inside something called the radiosphere. This represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And this extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signals, and then later, the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before the early 1930s, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year, so is anybody out there listening? And now, folks, I'm going to be adding these many markers onto the screen. These many markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed right now, so we've got a few years before they're completed and then launched into space. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system inside the radiosphere on the left-hand side. Let's say this far left right here, we find an alien civilization somewhere on the right-hand side. Let's say this one. We shoot them a text message. It takes 60 years to get to them. The alien civilization listens, answer back, another 60 years to get their reply message. Folks, that is a 120-year conversation in the making. Whew, and I can barely wait for a text message from my friend. But of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And I want to put away our exoplanet markers, but I'm going to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. And again, folks, we're now looking down on our Milky Way galaxy. This is the galaxy that we live in, and I have to ask, can anybody see their house from here? But folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. This thing is huge. And our Milky Way is so huge, we estimate that there's at least 300 billion stars in the galaxy. If our recent discovery of so many exoplanets just within our small neighborhood, within this vast, massive star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave it, I want to show you what it looks like from the side. You're going to notice that our Milky Way galaxy kind of looks like a big frisbee. It's really flat from the side. And this is important because when astronomers want to learn about the universe, it's much more easier for them to point their telescopes galactically north and galactically south, instead of looking to the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue zooming out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together, or they like to avoid each other where they create voids or where there's very few or no galaxies at all. So we can see a nice galaxy clustering towards the center of our screen. We can see some towards the bottom as well. We can see very few galaxies towards the top left of our planetarium dome. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, the picture that we're now looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tully, who created this amazing representation thanks to the work of other astronomers working aside him over decades of time. But now we have automated systems that are mapping even the most distant galaxies. So now we're going to be seeing the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. And by the way, the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of the Milky Way galaxy? Well, if we were to line up our Milky Way galaxy, it would line up just right down the middle, up and down like so. And again, we like to point our telescopes galactically north and galactically south. But astronomers still want to make sure that there was galaxies through the plane of the Milky Way, so we have this purple survey right here. You'll notice that they were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out all these areas that haven't been filled in yet. So it's just a matter of time. And that is a little bit concerning that we just lost the projector. Oop, it just came back. But let's continue pressing on, folks, because we only have a little bit of time left in our planetarium show. So now we're going to be encountering these really distant, far away objects known as the quasars. And the quasars are these orange dots represented on either side of the large-scale structure of the universe. And the quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years apart. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. What we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. And all evidence indicates the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny and vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go. So we only have one direction left to go. That's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. And let us make our return trip back to planet Earth, everybody. Alrighty, everybody, we're across an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy, with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, everyone, I want to remind you that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But hey, look at that, we made our way back into our Milky Way galaxy. We're heading straight for that radiosphere. And we're making our way back to our star system, our solar system, our little neighborhood in the vastness of space. And now, folks, we're about to pass those spacecrafts we sent on the 1970s to explore the solar system, passing the orbit of Pluto in the Kuiper Belt region, making our way to the third rock from the sun, our home world, planet Earth. All the people that we know, love, ever learned about in history, all lived on this one planet. And now, folks, we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And folks, if you enjoyed this show and you want to share with your friends and family, you can share this because this is recorded to the Morrison Planetarium Facebook page and our YouTube page as well. So feel free to share it with friends and family who were unable to make it today. But hey, look at that, folks. We made it back home to planet Earth safe and sound just in time for dinner time. And that's all for today. Thank you so much for stopping by, and I hope you all get home safe.